Physics, Part 202. Well, as we talk about the beam of the monochromatic light of wavelength, 630 nanometer transports energy rate of 0.25 MW. The Planck constant is h, which is equal to 6.6 into 10 power raised to minus 34 joules per second. Speed of light c is equal to 3.0 into 10 power raised to 8 meter per second. Number 3. The work function energy of a certain metal is 4.0 into 10 power raised to minus 19 joules. A. Calculate the longest wavelength for which photoemission is obtained. B. This metal is irradiated with ultraviolet radiation of wavelength 250 nanometer. Calculate for the emitted electrons. Number 1, the maximum kinetic energy. Number 2, the maximum speed. Number 4, calculate the Debye wavelength. Calculate the Debye wavelength of a ball of mass 0.30 kilogram moving at a speed of 50 meter per second. B. A bullet of mass 50 grams moving at a speed of 500 meter per second. C. An electron of mass 9.1 into 10 power raised to minus 31 kilogram moving at 3.0 into 10 power raised to 7 meter per second. D. A proton of mass 1.7 into 10 power raised to minus 27 kilogram moving at 3.0 into 10 power raised to 6 meter per second. The Planck constant is h, which is 6.6 into 10 power raised to minus 34 joules per second. Number 5. Atoms in the gaseous state, for example, low pressure gas, in a discharge tube produce an emission spectrum consisting of a series of separate lines. The wavelengths of these lines are characteristics of a particular atoms involved. Hot atoms in the solid state, for example, a hot metal filament in electric light bulb, produce a continuous emission spectrum which is characteristics of the temperature of the filament rather than the atoms involved. Suggest reasons for this difference. Number 6, figure 9.17 shows some transitions which may take place as excited electrons return to a lower energy levels. Calculate the wavelengths of the light emitted in each transition. Planck constant is h, which is equal to 6.6 into 10 power raised to minus 34 joules per second. Spread of light c, 3.0 into 10 power raised to 8 meter per second. Number 7, when the visible spectrum emitted by sun is observed closely, it is noted that the light of certain frequencies is missing. In their place are dark lines. A. Explain how the cool outer gaseous atmosphere of sun could be responsible for the absence of these frequencies. B. Suggest how an analysis of the spectrum could be used to determine which gases are present in the sun's atmosphere. Now we've got chapter number 10 here that says circular motion and oscillations. In one of the previous chapters we dealt with the uniformly accelerated motion. In this chapter we shall study two important examples of motions in which acceleration is not uniform: circular motion and simple harmonic oscillations. Both have very wide applications in physics and in everyday life. Understanding the physics of circular motion, for example, has enabled scientists to launch satellites into orbit around the Earth and to design theme park rides. Going round in circles. At the end of this section of the chapter 10, you should be able to describe some of the things that I provide in my next video.